In this lesson, we will be finding the greatest common factor using prime factorization as a strategy. Just a reminder, the greatest common factor is the largest factor two or more numbers have in common. The strategy of prime factorization may be easier when your numbers have quite a few factors to list. Let's start with the example 18 and 24. Our first step is to list the prime factorization for each number. You can find the prime factorization using factor trees or the ladder method. I prefer the ladder method. Starting with 18, we box it in, and we start with dividing by the smallest prime number, which is 2. 2 divides evenly into 18 9 times. 9 is not a prime number, so we box it in again. 2 does not divide evenly into 9, so I move on to the next prime number, which is 3, and 3 will divide evenly into 9 3 times. Since 3 is a prime number, we're finished with 18. Let's move on to 24. We start by boxing it in. 2 does divide evenly into 24 12 times. 12 is not a prime number, so I box it in, and 2 will still divide evenly. 2 divides into 12 6 times. 6 is not a prime number, so I box it in again. 2 still divides evenly. 2 divides into 6 3 times. 3 is a prime number, so I'm finished with 24. Let's list the prime factorizations for each number. 18 is equal to 2 times 3 times 3. 24 is equal to 2 times 2 times 2 times 3. From here, we're ready to find the greatest common factor. Our next step is to list all the factors or all the prime factors that each number has in common. As I look at 18 and 24, I notice that they have a 2 in common, so I can start with that. They also have a 3 in common. Therefore, I need to multiply a 3. Those are the only two prime factors that 18 and 24 have in common. So when I multiply those, I get 6, and that is your greatest common factor. At this point, I would suggest pausing and copying the steps down along with the example. Let's see what would happen if we're trying to find the greatest common factor of 3 numbers. We would follow the same steps. So let's start with 5. I want to do a factor tree or a ladder for 5. However, 5 is already a prime number. There's no way to break it down. So when I list the prime factorization for 5, I would simply say that it's equal to 5. Let's move on to 25. 25 I would box in because it's not a prime number. My first prime is 2. It does not divide evenly. My next prime is 3. It does not divide evenly. My next prime number is 5, and it does divide evenly into 25 5 times. Since 5 is a prime number, I'm finished with 25, and I can list its prime factorization. 25 is equal to 5 times 5. Our last number is 30. Box it in, and 2 will divide evenly into 30 15 times. 15 is not a prime number, so I box it in. 2 will not divide evenly again, but 3 will, and it divides into 15 5 times. Since 5 is a prime number, I can write the prime factorization of 30. It equals 2 times 3 times 5. Remember that the next step is to look for all of the prime factors that the numbers have in common. As I look at 5, 25, and 30, I notice that they all have a 5 in common. So I can start with that. That is the only prime number that 5, 25, and 30 all have in common. Therefore, that is the greatest common factor. Remember what that means. It means that 5 is the largest number that will divide evenly into 5, 25, and 30. For our last example, let's look at the numbers 7 and 32. I would follow the same steps. Starting with 7, I would find the prime factorization of 7. Since it's already a prime number, then I simply would write 7 equals 7. 32. 32 is not a prime number, so I box it in. It can be divided by my smallest prime number, which is 2. 2 divides into 32 16 times. That's not a prime number, so I box it in, and it can still be divided by 2 8 times. 8 is not a prime number, so I box it in. It can still be divided by 2 4 times. And 4 is not a prime number, so I box it in. It can still be divided by 2 2 times. And I finally ended with a prime number. Therefore, my prime factorization of 32 equals 2 times 2 times 2 times 2 times 2. When you look at the prime factorizations for 7 and 32, you will notice that they have no prime factors in common. This does not mean that there's no answer. It means that the greatest common factor of 7 and 32 equals 1, because all factors or all numbers have 1 as a common factor. Factors in common.